Hello everyone. I'm Gulsum Atici, RONDL, and today we will talk about how we can use OSM, the onboarding of OSM. There are descriptors packages, and we need to use those for onboarding process. We will explain what are the process and how we can use the descriptors and packages. We will first start with the OSM concepts, then network function onboarding process will be explained. What's network function onboarding, what are onboarding requirements, and what are the onboarding stages we are going to talk about. OSM relies on specs and we use an information model. So according to the information model, we produce some packages. The packages such as VNF packages or NS packages are uploaded, and we can create some network services. We can also create VNF virtual network functions, Kubernetes network functions, and we can use physical network functions, but yeah, this is a bit different concept. Now we are going to talk about those concepts. As we talk, OSM relies on specs, and we have a data model. This data model derived from the SOL6. We create our descriptors using the data model, and OSM network function and the network service packages formats are based on SOL4 and SOL7. Information model is quite important for us because we create our VNF virtual network function descriptor and network service descriptor totally compatible with the information models. So according to the virtual network function that we would like to use, we need to prepare a VNF network descriptor. And this descriptor should include all the requirements to give the required service. Then, after created the descriptors, we create the packages. How the packages looks like? VNF and the NS packages has some different formats. In a VNF package, we can see some directories and the files. VNFD YAML is the first file we need to look for because this is the must. It should include in a VNF package, but the others are optional. We can see a README file which explains what is this VNF package for. We can see a checksum.txt. It contains the checksum of this file. We can see images, scripts, icons, charms, and the Helm charts. Those are the optional, and they could be in the VNF package. You can see how it looks like, and a network service package may also include several files and directories. NSD YAML is the obligatory file for us, but the others are optional. We can also see some charms, scripts, and icons, a README file in the NS package. A VNF descriptor may include VNF connection points, constituent VDUs. We will describe what this VDU is in the next slide. VDU is virtual deployment unit, which is the smallest part of our VNF. The VDU dependencies, internal virtual links, VNF configuration primitives, and monitoring scaling parameters are included in VNF descriptor. We don't need to add all those things together, but some of them are required to be added at least to get a proper service from this VNF. A network service descriptor may also include NS connection points, constituent VNFs, VNF dependencies, virtual links, NS configuration primitives, and input parameters. If we look at the VNF descriptor, basically we can see two different sections. there is one section which is called the metadata, which is most the declarative part, and we can also see other part looks like operations regarding with the operations. It includes some parameters for the code, and this part could be used for VNF lifecycle, configuration, operation, and integration. What's VNF? A virtual network function. A virtual network function may include some deployment units. It includes some internal networks between virtual deployment units. It may include connection points, internal connection points which are interfaces. It may include some external connection points. What is VDU? VDU is the smallest part, as we told it. It could be a single virtual machine, and OSM able to define all the details regarding with this VDUs, such as CPUs, RAM, storage interfaces, and all other performance capabilities are allowed to define using the information model. Physical network function is a physical application which is already existed. We cannot manage its life cycle, but we can operate it. We can perform some operations on it. So we can get a control of its life cycle. We cannot get a control for its life cycle, but we can perform some operations. So we need a connection to this physical network function. So we can also define the PNFs and manage them using OSM. Kubernetes network functions, those are the Kubernetes applications, and those could be the pods or the services. And we, in the KNF part, we cannot create the networks directly. At the moment, we require that networks should be already present there, but we can indicate that this network is needs to be used for us. KDU represents could be represented by a chart, Helm chart, or Juru bundle. A network service may include more network functions. They could be hybrid. They could include KNF, PNF, and VNF. We need to define the connection points. We need to define the networks that's going to be used for this network service. So now we described the concepts, the terms which are used in OSM. Now we will look for the onboarding process. What is network function onboarding? What are the onboarding requirements, and what are the stages during onboarding? Network function onboarding is an automated process which is used to bring up new network functions. And modeling a network function is very important, because if we cannot model it properly, we cannot instantiate, and we cannot instantiate. After instantiation, we cannot get a service. We cannot scale in our audit, or we cannot expect the features that we would like to get. If we check the process, first we need VNF package, and we need to onboard this VNF package. Then the instantiation will happen, and we will get a VNF instance. Then we need to manage the life cycle of this VNF instance. It will start with instantiation, scaling. We can update it. We can run some actions on it. We can operate it. We can heal it, and we can terminate it. NF function onboarding starts by producing a VNF package. This VNF package is going to be a part of OSM catalog, and probably it will be used to instantiate the network services. then we need to operate some functions on it. So we need to manage its life cycle properly. It means this package should include all the requirements, instructions, and elements to achieve the lifecycle stages properly. So what are these stages, lifecycle stages? The first one is basic instantiation. We call it day 0. The second is service initialization, day 1, and runtime operations. We call them day 2. NF onboarding process, this is what we explained, shows also in here. The day 1 is makes the VNF manageable. Now we can access it. OSM can access those VNFs. Now we can manage them. This is day 1. If we would like to get a expected service just after initialization, we may require to run some scripts or run some do some configurations on it. Those parts are defined in day 2. This is day 1. This is day 1, and in a runtime process, if we would like to reconfigure it, monitor it, or we would like to run some operations on it, we call it day 2. Now we are looking for the requirements for these lifecycle stages. Basically we defined the terms, meanings. Day 1 is management setup. Day 0 is management setup. Day 1 is service initialization, and day 2 is reconfiguration. So what are the requirements for each step? Day 0 requirements mainly includes the description of VNF component, description for the NS, the description of NS component. What is included? What should be included in a VNF component? It needs to include the videos probably, and we need to define those are the minimum requirements that they need to include. After adding a video, we need to add internal virtual links, internal CPs, because we would like to interconnect those videos, and we need to map the video interfaces to internal virtual link descriptors. Those are the basic requirements which occurs the VNF component. For a NS component, we need to add external virtual link descriptor and external connection points, because we would like to make these components to be reachable. So we need an external connection for this. So at least those parts need to be included. For day 1, we expect to get a service from this VNF. So it needs to be configured, and we could get the expected service. What could be the main requirements? We can identify the dependencies between components. What are these dependencies? What could be those dependencies? We may require to identify some instantiation parameters. Maybe some components requires some parameters from others or infrastructure. Maybe we need to make their configuration just after initialization. Then we may need to reconfigure this VNF after initialization. We may require to identify the instantiation parameters, because depending on the environment, we need to pass some different parameters for this VNF, and those parameters needs to be prepared while we are creating the package, while we are creating the descriptor. Day 2 requirements. Day 2 requirements are used to reconfigure the VNF. So what could be those requirements? We can identify the dependencies between components. Some components may require parameters from other components. We need to define all possible configurations for runtime operations. Those configurations means those VNF could be in different stages, and we may need to configure it in a different way. So there could be several possible configurations. We may require to define key performance indicators. We may require to get some metrics. Those metrics could be collected from infrastructure or VNF directly. We can add some closed loop. We can define some parameters to manage the closed loop operations. What are those operations? Auto-scaling and auto-healing could be done on those VNFs, and we need to add the required parameters while we are defining our descriptors. So we explained what could be the requirements for the onboarding. Now we will look at the stages. Day 0, VNF instantiation and management step. Day 1, VNF service initialization step, and day 2, VNF runtime operations step. Yeah, as we already say, we are capable, OSM is capable to manage different types of network functions, and we may require to add different parameters for them. Starting through the VNF instantiation and management setup, we may require to add some initial configurations. Mostly we call them sometimes cloud init scripts. We need to reconfigure the host name. We may need to add SSH keys, configure the network device and users. Why we require it? Because this is the step that OSM needs to manage the network functions. So we are making it ready to be accessible by OSM. We can also add some enhanced capabilities by adding the huge pages, CPU pinning, and SRIOV. Those are also included in the day 1 process. Sample day 1 operations looks like, as we told before, building and adding cloud init scripts, setting an instance host name, adding public keys, setting up mount points, or adding user groups, and yeah, so there are different processes. Now we prepared our scripts, we write our descriptor, and now we are ready to create a package. How we can create the package? For the initial package, we can use OSM client to create us a package. OSM package create command could be used to create an initial package, and we can provide some arguments such as base directory, image, CPU, memory, interfaces, and others. Also, we need to say the package name needs to be created. Then an initial package will be created for us. For the network services, we can use the same command, package create, by writing the type of it. So it will be a network package, and the name is also identified using this command. After creating the package, probably our VNF is not ready, because still we didn't include our cloud init scripts and others. Now we need to modify it. We need to modify these descriptors to add all the required parameters for day 0. Then we can use another command to upload this package to OSM. This is OSM VNF package create command. We can give the folder of VNF just after the VNF package create, and this package will be uploaded to OSM. Now it is ready for test. Using the OSM create command, we can test its functionality. So this is a basic test of our VNF package. I'm not talking about this network service creation part because this is the topic of other session. VNF service initialization. We created the package, we added day 1 configuration, day 0 configuration, but probably it's not ready yet because we need to reconfigure our VNF services to VNF to make them ready to give the required service. What we need here, we can create a charm. We can add this charm into our package. We can edit our descriptor to integrate our charm with the descriptor to prepare our day 1 configuration. What is charm? Charms are the operation codes, and they can handle the lifecycle configuration, integration, and action primitives. There are two kinds of charms, proxy charms and native charms. Proxy charms are used for the fixed workloads. If we cannot modify the workload, we need to use a proxy charm. If we are able to modify the workload and our code can live in the workload, we can use native charms. There is also other way to configure our day 1 operations. Helm-based execution environments are also used for day 1 configuration. They launch the pods, and they can also do the same thing as charms. Day 1 operations could be defined in 2 levels in the descriptor, VDU level and VNF level. VDU levels, if our VDU needs to be configured different than the management VDU, then we can define some configuration in the VDU level. VNF level configuration may be used for the management VDU to make the VNF accessible generally. Usual-based or Helm-based execution environments could be used. Day 2 operations, runtime VNF runtime operations are also could be necessary. Why we require them? We may require to reconfigure the services in runtime. We may require to monitor the specific metrics. We may require to scale on monitoring analysis, and different operations may also required. So we need to add day 2 primitives to the descriptors. Day 2 primitives are defined under config primitives section in a VNF or VDU. Day 1 operations define initial config primitive. We are checking those sections in the next slide. How day 1 and day 2 operations done by using Helm-based execution environments. Helm-based execution environments are able to run day 1 and day 2 primitives by deploying a pair of extra posts in case namespace, and there is already a prepared Helm chart template for this named EE chart. If this EE chart added the under Helm charts directory in a VNF package, those day 1 and day 2 primitives could be executed successfully. How it looks like, how VNFD looks like with a Helm execution environment. If we check the execution environment list, we can see the Helm chart name, and we can also see the sections, initial config primitive, which are defined for they one operations here. We can see the parameters, and if we require to add day 2 operations, we can add config primitives only. Day 1 operations by using charm. For that one, we need to create a charm. We need to integrate charm with the descriptor, and how it looks like for VNFD. In VNFD, we can see the execution environment list, and we can see Juju and the name of the charm, which is identified in here. We can see some config access methods and config primitive for day 2. This is defined for day 2. It may also include initial config primitive. And we can see the parameters and their values or their default values. Thank you.